So, adding and subtracting uses the combining like terms or distributing the negative and then combining like terms. Multiplying complex numbers involves distributive property, FOIL, Punnett squares if you're using Punnett squares. The only thing that you have to keep in mind is if I squared pops up in the problem, which it most likely will, you must replace it with -1. So most of the times when you multiply, I squared is going to pop up. Multiply it times, you take the I squared out, put in -1, and then you keep simplifying. So, go through 4 examples of multiplying, which again, if you're comfortable with distributive property and FOIL, then solving these are not really that difficult. So, example 1 is basic distributive property. 6i times 3, 6i times 2i, 18i plus 12i squared. But I squared came into the problem, so replace it with -1. So you get 18i minus 12. So the only thing you have to do here is to make sure you put it in standard form. 18i minus 12 is not in standard form. The I part of the problem always goes last. So your answer is -12 plus 18i. So you do need to write it in standard form. Write your final answer in standard form. The one that's above it technically is wrong. It's not in standard form. So, basic distributive property. Example 2 is basic FOIL method. So if you do the FOIL method, that's 12, 9i plus 8i plus 6i squared. Combine our like terms. 12 plus 17i plus 6i squared. Again, I squared is equal to -1. 12 plus 17i. 6 times -1, which will give you -6. Combine your like terms. You end up with 6 plus 17i. So again, computation is not that hard, not that bad. Main thing is to I squared is equal to -1. Just pay attention to the minute details. Questions, examples, 1 or 2. So, examples 3 and 4, couple variations with multiplying. So example 3, either 3 plus 4i and 3 minus 4i, which the only thing that's different is the sign in between. I'll put a star by that one because we're actually going to see this problem again in a few minutes. but we still do distributive property FOIL. 9 minus 12i plus 12i minus 16i squared. Couple things to note. Negative 12i, positive 12i, those are going to drop. I squared is equal to negative 1. You get 9 plus 16, 25. So sometimes the i's will drop out and you'll have just a single number as your answer. Perfectly fine with that. And then example 4, 5 plus 2i squared. So again, there is the wrong way to do it. And that's 5 plus 2i, 5 squared plus 2 squared, I squared. So all you see over here is the 100% wrong way. So please don't do it the wrong way. The reason why I tell you it's the wrong way, right? It's squared. Write it twice. Then do FOIL. So 25, 10i, 10i, 4i squared. And then do your simplifying from there. 25 plus 20i, 4 times negative 1. So that's negative 4, so you end up with 21 plus 20i. Again, do not write the I first. That's technically not in standard form. It will get marked wrong. So, any questions on multiplying before we continue? All right. Not seeing or hearing any, so let's switch to dividing. So, with dividing, there is one thing that we need first, and that's the idea of a complex conjugate. So, a complex conjugate is simply the opposite of a complex number. That's all it pretty much is. So, if you have A plus BI, then the complex conjugate is A minus BI. So simply change the sign attached to the imaginary part of the number. So if you had 5 plus 3i, then the conjugate is 5 minus 3i. Negative 1 minus 2i, conjugate is negative 1 plus 2i. So that's all that it is. That's what a conjugate is. Now, if you multiply two complex conjugates together, then the answer you get should be equal to a squared plus b squared. So, think back to example 3 when we were multiplying. So, there's example 3 when we multiply. We got an answer of 25. 3 plus 4i and 3 minus 4i, those are complex conjugates. I just didn't tell you what the formal name of it was yet. So we know that this answer is 25. We've already worked it out. But if we look at the problem, 3 is your A value, 4 is your B value. So that means if you see that they are complex conjugates, then you don't have to do FOIL. You simply have to work out a squared plus b squared. So that's 9 plus 16, which is still 25. So if you're wondering, well, what if I use the other conjugate? Same thing. Three squared plus negative 4 squared amounts to the same thing. So either way it goes, you get the same answer. So if they're conjugates, it actually gives you an easier way out. Gives you a little bit of a shortcut. So any questions with conjugates before we shift to dividing? The nuts and bolts piece before we do dividing complex numbers. So, last thing with complex numbers is to divide them. So dividing complex numbers is more so tedious than it is anything else. And it's step-oriented. So, step 1. Find the complex conjugate of the denominator. So in the case of example 1, 3 divided by 1 minus I. So you find the complex conjugate of the denominator, which remember is just changing the sign on the imaginary part. Then multiply that number. It should say numerator. Now you see why I don't teach English. Multiply the numerator and denominator by the complex conjugate. Multiply the top and the bottom by the complex conjugate. So if we do that, you get 3 plus 3i at the top. At the bottom, so remember you can use the shortcut that I told you with multiplying by the conjugate, or if you don't want to use the shortcut, you can always multiply it out using FOIL. Doing it the FOIL way is a good way for you to check your work anyway. Let's see, 1 plus -1 times -1, 1, so that's 2. So you get 2. So, if you did it correctly, the denominator should just be a single number. You should just have a single number in the denominator, if you did it correctly. After that, you just divide. Divide the top and the bottom by 2. 3 over 2 plus 3 over 2 I. So again, the answer has to be in standard form, which takes care of that. If they end up as fractions, my advice would be to leave them as a fraction. Make sure to reduce it, but leave them as fractions. Don't change them to decimals, because if you end up with a decimal that doesn't round off nicely, then you've got problems. So leave it as a fraction, that's it. Any questions? Example number 1. If you have questions, make sure to ask, because closed mouth don't get fed. If you're sitting on the couch watching early morning cartoons or still sleeping, make sure you know what you're doing, because you still have a quiz tomorrow. Example 2. 8 plus 20i divided by 2i. Same rules apply. Doesn't matter if there's just one part down there. Actually, in this case, that's an imaginary part. Complex conjugate, -2i. So multiply the top and the bottom by -2i. So if that happens, you get -16i minus 40i squared over -4i squared. So we got a lot of I squareds going on in this problem. That's okay, we've got a way to take care of it. So I squared is equal to -1. So the top of the fraction becomes 40 minus 16i. I squared -1. Bottom is 4. So this one actually works out quite nicely. 10 minus 4i. So that's the standard rule for complex numbers. That's a property. I squared is always equal to -1. So yesterday, when we started complex numbers, let's see, working out. So I is equal to the square root of negative 1, that means I squared would be the same thing as the square root of negative 1 squared. But a square and a square root is going to drop out, which leaves you with negative 1. So that establishes the property for I squared. So anytime you see I squared, it drops out. If you leave I squared in the problem, it's automatically going to get run wrong because there's a property for it. Questions, example 2. I'll give you a moment to start example 3. Yep, you only use the denominator for the complex conjugate. Numerator will always stay as is. So excellent question there. Alright, so let me give you a moment to example 3. So there's 5i over 2 plus 3i. So again, the same rules apply. You take the complex conjugate of the denominator, which would be 2 minus 3i. And that's what you would multiply the top and the bottom line. Then we go to simplify the expression. So 10i minus 15i squared should be at the top. If we work out the bottom, you would have 4. The middles would drop out, minus 9i squared. Take care of our I squareds. Remember, do not leave I squared in the problem. 15 plus 10i over 13. Then it's just breaking it apart and simplifying. There you go. Do not leave it as, well, that you do have to separate. So don't leave it where I placed the star. That's wrong. It's not simplified. So again, I'm looking at this, looking at it from eventually, you're going to go to pre-calc honors. They will ding you for not simplifying a complex number. Questions before we look at example 4? All right. And let's go ahead and finish off with example 4. Same thing, give you a look at example 4. So example 4, take the complex conjugate and multiply it by the top and the bottom. So that's 2 plus 3i times 4 plus 2i. So again, the whole point of the complex conjugate is to get the imaginary number out of the denominator. Look out the top, you have 8 plus 16i plus 6i squared, and then 16 minus 4i squared at the bottom. Let's simplify and take over. I squared is negative 1. So you end up with 2 plus 16i over 20. Divide it out, which is separating it into the fractions. And of course, you can't leave it like that, those aren't reduced. So if you know how to simplify, then working with complex numbers is actually really not all that difficult. Questions before we wrap this up?